Introducing TOR-1 from PDI Media.
TOR, T-O-R, is short for Tune-O-Rama.
TOR is MIDI and audio software that helps musicians and sound designers control the tuning and pitch of their external MIDI sound sources. TOR-1, like all PDI Media applications, runs on both Windows and Macintosh computers. It is the first installment of the TOR series. TOR-1 provides a variety of functionality for MIDI instruments. It can create and send MIDI channel tuning information. It can create custom MIDI note scale maps. It can create repeating microtonal tunings and scales. It can manage the pitch bend range for up to 16 channels. It can combine multiple MIDI voices, each with separate tuning, pan, and volume information to create superstack instruments. It can display tuning information in a variety of ways, including 14-bit pitch bend, frequency in hertz, and bend amounts in cents. And it can give the user real-time external control of pitch bend on 16 independent channels. All settings can be saved and recalled as presets and projects. The presets can be chained and looped to create programs with many different tuning settings. Let's take a closer look at what TOR-1 can do. To launch TOR-1, navigate to the application folder and double-click on the .exe executable file in Windows, or the TOR-1 application file on Macintosh. When the application appears, we'll start by loading a project. We can do this either by opening an existing project from the File menu, or by creating a new project. For this demonstration, we'll be opening an existing project. When the project is loaded, you'll see its title and its preset slots in the preset area on the right. To load a preset, click on any of the blue square slots. Notice that the application parameter values change. TOR-1 was designed to work with multi-channel, multi-timbral MIDI sound sources. It works best when you have access to at least 8 separate MIDI channels. Let's walk through each of the functional areas, starting with the MIDI section. As you'd expect, the MIDI section controls how the application interacts with external devices and sources. Clicking the Scan Ports button tells the application to search for available MIDI ports. Use this button if you have connected a new MIDI device after you started the application. The Use Preset Ports button toggles between on and off. When on, the application will store and recall the port information selected from the port menus. When off, the application will ignore the saved preset port information when a preset is selected or recalled. The MIDI in port lists all available MIDI ports. The port you select will be used to receive the note and control data used by the application. You can receive on all channels by setting the channel number value to 0, or you can specify a receive channel. Selecting a value from 1 to 16 will ignore incoming data from all other channels. The MIDI outport menu allows you to select from a list of available ports. All data generated by or passed through the application will be sent out the selected port. Turning on the Through button in the MIDI section passes any incoming MIDI data directly to the output port. This merges the outgoing processed data with the original incoming data. If the Through button is on, clicking on the Filter Notes button will not pass any note data through to the output. All other MIDI information will be passed through. If the Through button is off, the Filter Notes button is set to off, and is made inactive. The Channel Tuning RPN section sets the coarse and fine tuning in semitones and cents for individual MIDI channels. Many modern synthesizers no longer respond to these messages, but some of the older ones do. Some MIDI devices use a single program change number to select the sound. Others, with more than 128 sounds, use a combination of a bank controller number, a controller value that describes which bank, and finally, a program change value from 0 to 127. The program change section allows you to send program change messages to your external multi-timbral instrument. To send a program change to just one channel, set the current channel value to the channel you wish to send the program change, and then select the program change number. Clicking on the Send to All button will send the selected program change to all 16 channels simultaneously. For Kurzweil PC4 users, we've added the ability to select banks and programs with one PC4 program ID. When the Use PGM button is set to on, the saved program changes are sent to your external instrument when a preset is selected or changed. When the button is off, the program change will not be sent when the preset changes. The MIDI specification allows for bending a pitch anywhere between 12 semitones up and 12 semitones down. This gives you potentially 2 octaves of pitch bend per channel. In the pitch bend settings section, You can set the range by selecting the number of semitones in the PB range number box. Clicking on the Send to All button sets the pitchbend range of all 16 channels to the selected value. The pitchbend range value is saved with each preset. Recalling the preset sends the bend range message to all 16 channels automatically. Clicking on the Panic button sends note off messages to all 128 MIDI notes on each of the 16 channels. Use this button to turn off any stuck or hung notes. Now that we've seen some of the basic control functions of TOR1, let's take a look at its main functions and features. TOR1 operates in two modes, normal, multi-mode, and unisono mode. We select between the modes by toggling the mode button. Notice that some parameter and function options change. Both modes use the scale settings function. The scale settings parameters specify how you want to map incoming notes to the outgoing pitches. This complex functionality will be described in depth in another video tutorial. For now, we're going to make sure that we set both our steps/voices and our scale range parameters to 12. This means that our scale will have 12 notes, and those 12 notes will span one octave. You might have guessed that this describes a normal chromatic scale. In this case, we can set the scale start value to any C note octave. Let's use middle C, which is C3. The application will extend this mapping up and down the keyboard. When a note is sent to TOR from an external source, it is first transposed to the MIDI note it is mapped to. We set the output transposed note value directly under the note in value. For now, let's set the output transpositions equal to the corresponding input notes. This means you will hear the same pitches from TOR that you play on your keyboard. We can always set the note out pitches to their default value by clicking on the Note Default button. Now, we can create microtonal tunings. For example, let's create an old keyboard tuning from the 16th century. Remember, the common tuning that we use today, equal tempered tuning, wasn't yet invented in the 16th century. This scale is a variation of mean tone tuning, which tries to tune the keyboard so that some of the main intervals are perfect integer ratios, while manipulating other pitches so that they sound acceptable in a variety of keys and chords. We set the tunings by clicking on the tuning slider. Or, to be more accurate, we change the 14-bit pitch bend value so that the bended frequency is the desired amount in hertz. This scale uses only 12 steps. Note that only the beginning C is left unbended. Let's listen to a musical example. We can change the note mappings and pitch bend settings to create interesting musical effects. In this scale, we've mapped each of the 12 scale steps to the same pitch. C3. We've set the scale range to 1 semitone. Next, we set each successive pitch bend value to be an ascending amount from none to nearly 1 semitone. This provides a scale where 12 notes span 1/2 step. This places the scale notes very close together, pitch-wise. Playing a 2-octave chromatic scale on the keyboard sounds like this. Note that the yellow monitor light shows us which note is being input. Here's what an excerpt of a Mozart piano sonata sounds like in this tuning. With TOR1, we can create intervals in just intonation. For example, we can create fifths that are truly perfect 3:2 ratios.
In this example, note that the notes G, G sharp, A sharp, and B are precisely 1.5 times the frequency of C, C sharp, D, D sharp, and E.
When played, these intervals create a pure tone with no beating. So far, we've been building scale maps with 12 steps that span 1 octave. But TOR can build repeating scales with up to 16 steps that span any interval. In fact, we can build scales where the mapped notes don't even follow the pitch direction of the input notes. These scales can produce unexpected and musically interesting results when played from a traditional keyboard. This preset is a scale that has 6 steps and spans 7 semitones. This configuration means that the notes played on the keyboard produce mapped notes that are unexpected, yet related, and different notes in each octave. We've also turned MIDI through on, which passes the input note from the keyboard through unaffected, and merges it with the mapped notes. We're playing only major and minor triads, but the result is complex chords with 3 and 4 voices in rich harmony. TOR 1 can also operate in Unison mode. In this mode, each incoming MIDI note is mapped to all of the channels as set by the steps voices parameter value. We can stack up to 8 voices to create complex, powerful sounds. We use the spread dial to set varying amounts of pitch bend to thicken the sound even more. The spread scaling factor allows us to multiply and fine-tune the spread effect. Selecting a jitter range dynamically changes the bend amount independently for each channel. Clicking on None resets the jitter amount. Clicking the Show Mixer button displays a window where we can assign volume and pan amounts to each of the 16 channels. This information is saved and recalled with each preset. TOR can also tell you the frequency of an external audio signal. This is useful when checking the actual frequency of bended pitches. To check the frequency of an external audio source, first make sure that your audio engine is turned on. Then, open your audio preferences by clicking the Show Prefs button. In the audio status window, select your external audio input source and close the window. The pitch of the selected source will be sampled, and the application will display the sampled frequency. Adjust the input gain so that the audio monitor light turns on when triggering the external audio note. To map incoming MIDI controller information to a function in TOR, we go to the Mappings menu at the top of the screen. From the Mappings menu, we select MIDI Mapping mode. This puts the application into MIDI mapping mode. Now, to map a channel for external control, we click on a 14-bit PB value number box. Then we wiggle the continuous controller we wish to map to this channel. Note that the value of the selected number box changes, as does the bend status slider. The controller is now mapped. You can repeat this process with each of the 16 channels. You can map many other functions in the same manner. When you are through, just hit the Escape key on your computer keyboard to exit mapping mode. Your external MIDI controller can now send independent pitch bend information to each of the map channels. TOR allows you to save 90 presets per project. Each project also saves the external mapping information and the preset client object file. To save data as a new project, just go to the Application File menu and select Save Project As. When prompted, select a location for your project, give it a name, and click on the Save button. The preset data file, the mapping file, and the preset client object file will all be saved in a newly created folder that has the name you specified. After the project is saved, you'll see the project name appear above the preset name text box. In this video, we've seen a lot of what TOR 1 can do. But we don't have time to show you its complete capabilities. Advanced features, such as scale mapping, MIDI mapping, keyboard mapping, and client list customization will be the subjects of future videos on this channel. We're also preparing a sound demo that shows how TOR 1 can be used to create unique musical effects that can enhance any production. So, subscribe to this channel, and stay tuned.
Hi everybody, I'm Alan Dudek, the developer of PDI Media software. Thanks for watching our video. I hope you find our products interesting and musically useful. You can download our applications on Gumroad. Please subscribe to this YouTube channel for updates on this application and for video demonstrations of our other software products. You can also visit us on Facebook at the PDI Media Software Users Group, or if you have any questions or comments, just email directly at adudek@columbus.rr.com. Thanks for watching, and I hope to hear from some of you very soon.